Howdy folks. In the last video we took a look at how to read an algorithm prompt and really what algorithms are good for and why we care about them. In this video we're going to take a look at how to break down those algorithms and actually get some kind of semblance of how to solve them. And really to do that we're going to start off by saying how do we figure out generally what we're trying to do from the algorithm. Let's get into it. So to start off with, this is the algorithm we were looking at last time. ToSum. Given an array of integers nums and integer target, return indices of the two numbers such as they add up to target. You may assume each input would have exactly one solution. You may not use the same element twice. We looked at these inputs, this target, and the output, and we understand kind of how they got there, right? But let's really look at that, okay? So if I look at 2, 7, 11, 15, target 9. This is going to give me all sorts of errors because it's actually looking at C++ code, but that's okay. If I gave you this, and imagine, and this is the first step to figuring out any algorithm, is you have to understand what you're doing. Not just read this and say, oh yes, I understand those words. I understand how those words go together. I can English. No, it's more deeper than that. It's saying, okay, what does that mean? If I give you 2, 7, 11, 5 and target 9, solve that. Tell me the answer. Well, you look at that pretty quickly and you say, well, the answer is 0, 1. Yeah, that is the correct answer. I mean, you could also look over here to get that. Let's do a slightly different one, okay? Let's say I gave you 5, 8, and 4, okay? What's the answer there? Well, the answer is 0, 3, right? Because these two add together get to 9. Cool. How did you do that, though? You probably just scanned these through and said, okay, well, which two of these add up to 9, right? That's a good step, but you're missing some parts. How did you do that, all the steps? And this is the part that people have a lot of trouble with, I find, is if I give you something like this, you say, oh yeah, it's 5, 4, 5 plus 2 obviously is not 9. You know that immediately. You look at the 8, you're looking for a 1, okay, there's no 1. You look at the 4, okay, I know 4 and 5 together. That's it. Maybe more interesting one. If I gave you 11 and -3, or -2, then the answer for that one becomes 1, 2, right? Because 11 minus 2 is 9. And none of these other two add up to become 9. We knew that just because we looked at those again and add them all together, but we need to go deeper. We need to go simpler. The way I like to tell people is imagine you're explaining this to a 3-year-old child. It'd be a genius child who understands numbers. But the computer doesn't know anything. It knows very basic things. You can't just tell it, scan this whole list and find two numbers that add up to 9. Maybe you can. Maybe your standard library actually has that ability, but it's kind of unlikely. Or at the very least, you're having to write some code to explain to it what that means. So how do we really do that? Well, we start off, this is just an example. For every algorithm, this tends to be a little different. I'm going to look at this and say, okay, well, if you gave me this and told me to find 9, first I'd look at 5, okay. First 5. Then I compare 5 to all other numbers and add them. 8 or 9, we found it, right? So I'd say, okay, 5 plus 11, no, that's 16. 5 plus -2, that's 3. 5 plus 6, that's 11. That's funny. Well, none of those are 9. Okay, well then we move on. 11 compared to all other numbers. And in this case, I wouldn't look at the 5 past 11, right? Because why would I look at the 5? I already did 5 in the previous list, so I'm not going to look at it again. Okay, 11 and -2. Okay, that's 9. We found it. But hey, I found it, right? I found it. 11, -2. I found 9. Cool. I know there's only one solution, so I'm done. I don't even bother checking 11 and 6. I don't check -2 and 6. That's basically how I go through it. Now, you can already see, I wrote this way specifically. There's already some similarities here, right? Okay, let me change this and add them just to kind of clarify a little bit more past 5. There's a generic here, right? I have read this in. I now understand how this works, and I now have a series of steps, okay? first of all, look at first number. Compare to all numbers past this one. Number. Add. Well, you know, compare is a bad word. Look at. Let's just say look at all numbers past that number. Add first number and past numbers. I'm going to use after instead of past. You know, the words you use matter. If 9, done, finished, hooray. Okay, then we want to go on to look at the second number, etc., etc., but you can already see this is kind of turning into pseudocode. And I did that very quickly because I'm very experienced with this. But the idea here, this is the important part. How did I do this? Let's look at another example. Let's look at palindrome number. Given integer x, return true if x is a palindrome, false otherwise. Let's just look at one of their examples here. 121. Is that a palindrome? Yeah, you know it's a palindrome. How do you know it's a palindrome? What's a palindrome? Well, a palindrome is where it reads the same way forwards as backwards. Right? So, let's see. Okay, how do I know that this reads the same way forwards as backwards? Well, I start with the first character. I compare it to the last character. Are those the same? Yeah, cool. We're still a palindrome. We go on. 2. Well, 2's in the middle, and the middle is always a palindrome with itself. So, now we've gotten to the middle. Everything's a palindrome. We're great. What about this one? This is actually not a palindrome. But how do we know that? Because that 2 doesn't match with that 3. But if we were to look at that very closely, first we start on the outside, right? We compare those 1s. We move 1 in, we compare the 4. Okay, still equal. We get the 3 and the 2. Oh, they don't match, not a palindrome. That's another series of steps we can write out and put down. And so this is really important because, and I've seen a lot of people do this in interviews, they start just running off and going crazy trying to build their algorithm, and they don't actually fully understand how it works. And then after about 10 minutes, they ask me a question that tells me they really didn't understand what they were being asked to do. So honestly, even in interviews, I sometimes will go through and just come up with a solution and say, this is what I expect the output is. Does that look correct? To the interviewer, because they'll tell you if it's wrong. They don't want you to fail. Well, I mean, if they do want you to fail, you have a bad interviewer, and that's, you can't do anything about that. But you need to know what you're building. And that's why looking at the algorithm and figuring out exactly how you would do it means that that's the first step to being able to tell the computer how to do it. And it's actually a really important step that a lot of people miss. So, this is how to figure out an algorithm and figure it out yourself. It really just comes down to 2 steps. Very simple. Get an example. Figure out what the answer is yourself, make sure it's correct, and then write down in excruciating detail every single step you went through mentally to get to that answer. Hope this is helpful, folks. Have a good one. I'll see y'all next time.